I audible? If you can hear me, say, woo! Awesome, you're awesome audience. So yes, as you heard, my name is Joylynn Kirui. Way to start a speech, my mouse just fell. So how many of you guys are expecting nuggets to be eaten? Oh my. I'll organize with the organizers, yeah? Yes. Okay, so my name is Joylynn Kirui, and I'm sure you're wondering, so what are we going to talk about? So bolstering the security-first mindset. So maybe I'll just start off by introducing myself. So first off, I'm a human, not a robot, definitely. On a day-to-day, I'm a senior cloud security advocate at Microsoft, and I do application security and DevSecOps. So that's my job on a day-to-day. And apart from that, I am also a cybersecurity evangelist. I train developers. I do a lot of consulting as well, and mentoring. In Kenya, I have mentored, I think, more than 30 universities. Yes, and I also do, I don't know, you guys do know of ADP List. ADP List is a platform for mentorship. So if you're interested in cybersecurity as well, you have a couple of folks there who are ready to mentor as well. I'm also a farmer. I live in a farm in the Great Rift Valley in Kenya. How many of you guys know of Kenya? What do you guys know about Kenya? Yes. Safari, What else? What? We got what? Ngong Hills. Nice. That must be a hiker. What else do you guys know about Kenya? No one? Elephants. Yes, we have plenty of them. We have plenty of lions, plenty of all that. I'm also an adventurer. You can see me paragliding over in Cape Town. I remember sending that pic to my mom, and she got really scared. So apart from that, these are just a couple of recognitions which I just put there. So yes, Vanguard, which is just a recognition from the young CISOs in Africa, Woman Hacker of the Year finalist, as well as top 50 women in cybersecurity in Africa. So I mainly do offensive security stuff. And I think, so I can just say that during this whole session, I'll just be sharing what I have learned, starting off a DevSecOps initiative, and the learnings from my failures, and some of the learnings from my successes as well. So I don't know if you guys are all know what DevSecOps is. How many of you guys know? Just there? How many? If you raise your hand, I'll ask you questions, by the way. So we'll start off with a couple of cool stats. So you'll find most of the elite software organizations, they push code 200 times more frequently. And they also have 7 times fewer failures on deployments. And also have 8 times more likely to have integrated security. If this is you, kudos. You also have 2 times more likely to have internal communities of practice, and as well as 100 times faster setup of dev environments. So this also results in 4 to 5 times higher revenue growth. This is why it's quite important for us to understand why integrating security in your development lifecycle is quite important. So you'll find 52% of companies actually sacrifice cybersecurity for speed. So one thing that was quite prevalent in our day-to-day is that I remember, let me just give an example from the waterfall way of working, from the way I have done cybersecurity in the past, and working with developers. So if any developer that I've worked with before, and maybe they'll be watching, I apologize for being a showstopper sometimes. So you'll find that in the normal waterfall way of working, you find vulnerabilities and you generate a whole report of vulnerabilities and give to the developers. They have no idea what this is. This is part of cybersecurity that we've been doing quite wrong. We are pushing a lot of reporting to developers without even explaining to them what exactly they're actually trying to fix. So what I'm going to talk about is how we can foster this and have a security-first mindset for developers as well as the operations teams. We have 57% of ops teams who push back on security best practices. I've seen scenarios whereby we are almost going to production and then you find a critical vulnerability in one of the packages and then they say that that particular, if they upgrade, the whole system won't work, especially for legacy systems. How many of you guys have experienced that? And then now the business is expecting you to push the deployment date to be the following day, and then now because of the security vulnerability, you have to have like 2 weeks of delay, isn't it? And then we see 44% of developers are not trained to code securely. Can you hear me? Yes. It's above that. So a lot of developers actually don't know how to code securely. So I'll give you my example. The way I dived into cybersecurity is I was a full-time software engineer, and I got hacked. So one time I was developing systems, even being recognized in Kenya in the newspaper for some of the systems that I was developing. And I remember one time I was not keeping any security best practices at all when developing. And then one time, one of the systems was actually hacked. So, and then I was like, how can I better secure? How can I build better products? So went up and just did a lot of Googling and did a lot of research to find how to best do secure products. And there is one place that I've seen, there is very little resources for developers to learn how to code securely without overwhelming them with all these security jargons. Because in my best opinion, I would say that for developers, we should train them only what they need to learn. By that I mean, if you want them to fix a particular, so I remember doing developer trainings beforehand. And I would have all these OWASP top 10 vulnerabilities and present it to them. Remember, I don't know if you guys have had like that presentation whereby you're just sitting there and listening to all these vulnerabilities, which is just like 1 hour, and then you're like overwhelmed. What is this person talking about? So in my understanding and in my opinion, we should be talking to the developers only what they need to do their work securely. And by that, it's all about automation as well. So we'll capture that as well. So you'll find that more code is directly proportionate to more technical debt and exposure. The more you push code, the more your chances of being exploited. True? We find that flaws in applications are consistently the #1 attack vector for breaches. So this is according to Verizon. I know according to the different statistics, you'll find maybe you'll find different attack vectors, but according to Verizon, application flaws are consistently the #1 attack vector for breaches. Another great stat is you'll find that 80 to 90% of code in new applications actually come from open source. True? And how many of you guys actually know what is in that open source integration? Like this? Almost? Yeah. So, and this is where we have the problem. Whereby you're integrating all these open source libraries, all these packages, without even knowing what vulnerabilities it's bringing into your code. And we have that problem where we have 570 times more developers than security researchers. True? So working with developers, I would be working with like, let's say 150 developers, and I would be working alone. And you can imagine the level of commitment that you have to do when you're testing your systems and giving them reports, and then they're pushing back and saying that this can't be done, and you are just one person. That's why we need to train and have security champions. How many of you guys are actually security champions? Like, okay, you're here, so I'm expecting you're all security champions, yeah? So I'll give, from my experience, how I went ahead and built a DevSecOps adoption in a previous company, and went ahead and also had security champions as well. So one thing that I've seen most of us doing very wrongly is adopting too many toolings. You see this tool, you try and integrate it. You see this tool, you try and integrate it. How many of us are guilty of that? Just one? Two? Okay, three. So, and without even trying to adopt or tweak those tools for your particular environment. So you have to be very specific on what your environment needs. What language are the developers using, and what tools can actually solve your particular needs. So this is where I say that you have to take a lot of time during your POCs. During your proof of concepts, just take time to understand, is this tool actually fixing what I need to be fixed within your tool chain? Try and understand if this has false positives. I remember once integrating this commercial tool, and then it took more to troubleshoot the false positives than to actually fix those security vulnerabilities. So you can imagine in that extent whereby developers, you're giving a report to the developers, and then they're like, this is actually not true. Yes? They're saying that this is actually a false positive. That's why we have to work to make sure that we tweak our tools that you're integrating to make sure that there are less false positives. So other sources of vulnerabilities within our code are unchecked dependencies, which count for 80 to 90% of our code. And then we also have employee error, which has exposed access tokens, unsafe code patterns. And this is where I've even seen guys even having like your API tokens hard-coded. You have hard-coded passwords as well. I have seen a lot of things in applications while trying to reverse engineer them, and it's just amazing. And there's also damage in exponentially greater if it reaches in production. Because remember, the cost of fixing a particular vulnerability is way higher when you are in production. So this is where we have to talk about secure software development. So in secure software development, developers want to know how they can best maximize developer velocity. How can they be able to do their day-to-day job in an easy way and to do their work in the best way possible? Developers also want to understand, how can I eliminate developer complexity? When you're there and integrating so many tools and making it so hard for developers to do their work, by increasing complexity, they'll start seeing security as a showstopper as well. And we have to work collaboratively with developers to make sure that we are having a shared responsibility, a shared accountability. That's why we say security is everyone's responsibility. That's why we have to talk about secure software development as much as possible. And we also have to empower developers to contribute. I usually say developers know whenever they are using improper functions. They know when they have done wrong code. They know when they're not using the best practices. So they are our first line of defense. That's why you have to take time to train them well, to train them on the best tools that are actually easy for them to use, and to train them on how to actually fix those vulnerabilities. On the other hand, CISOs want tools that detect vulnerabilities and stop them as early as possible. They want to partner with developer teams as well to push systems as fast as possible. And they also want to have proactive hunting. By proactive hunting, we mean that they want to, whenever a vulnerability is released, your systems actually block them. So what can we do? This is where we talk about DevSecOps. What actually works for developers as well as CISOs? That shared accountability between them. So this is where we have to have the secure development environment and embed security in the developer workflow. So throughout the development lifecycle, that's when we are talking about planning all the way until a system is in monitoring. We have to integrate security in every stage of the software development lifecycle. So you guys have heard me say DevSecOps. So I'm sure most of you know what this is, but I will just explain it. So DevSecOps is the evolution in the way development organizations approach security. So this is where we are trying to have a security-first mindset culture and automating security within every phase of the software development lifecycle. So one thing that we've been doing DevSecOps really wrong is really emphasizing on the tools, while we should be emphasizing on the culture, on the security-first mindset. So I have seen scenarios whereby there's a breach, and then now you have to drill down to the developer who actually put that code or pushed that code. And then there would be consequences for that developer. You can imagine what kind of toxic environment that would be. So by having a security-first mindset and culture, we want to eliminate the blame game as much as possible. Every one of us is responsible for that particular product or system security. Okay? So this is where we talk about working together as developers, as the operations team, and as well as the security team, working towards the greater good. So there are several benefits of deploying DevSecOps initiative within your organization. So these are the main three. So it reduces the remediation time by shifting security left. And you can integrate with the security with your existing tool chain. And then lastly, you quickly identify new threat vectors. So as we mentioned even earlier, by shifting security left, you identify issues as early as possible, and you fix these vulnerabilities on the go. So one thing that I am quite keen on is developing for developers, whenever they are coding, even from their endpoint, you make sure that you have security integrated within their IDE. So by IDE, what tools do you guys use? Yeah? You said which one? Oh, I can hear. Yes? You use? Okay, maybe you can just come and mention that. Which tool do you guys use? Which you've actually integrated in your IDE for security? Yes? Okay. Yes. So, yeah. So there are several tools that you can use. Even you install the extension like CodeQL as well as Sneak, whereby you train your developers just to scan your code as well whenever they're coding, and identify the issues as they go. So the importance of shifting security left. So you have 80% reduction of security incidents by extending security into development. And you also have 60 times the security cost is reduced whenever you fix the security as early as possible. So we have 62% of enterprises which actually do not integrate security into the development phase. And I'm hoping we all change this. That's why we are talking about shifting security left. So whenever we have trying to deploy a DevSecOps adoption, we also face certain challenges. So we have the organization and team gaps. So very many of us actually find that the operations team, they work separately from the developers team, and the security team also work separately. So we don't work together. We don't have that kind of synergy. So that's why we have to be quite intentional about working together. So even if it's having team lunches, even if it's having team meetings, we have to have these together. We have to be quite intentional about that. And as well as having the skills and knowledge gap. This is why we're trying to empower the developers by having even security champions. By security champions, we mean identifying those people who actually are curious about security. So that's why I was mentioning, within the different squads, within the different development teams, you identify there's always that one person who is very curious about security. So you use that person and you empower them as much as possible with the relevant security tools as well as knowledge. So one thing that I did when I developed a DevSecOps initiative in a previous company is you have a security champion, at least one or two within the team who actually have some form of command or who can have influence on others. So whenever they have their sprint planning, they can be able to even stop and say that, no, we shouldn't be doing that. We should be doing this we should be doing this the other way. And then another way is now training those developers as well as security champions every so often. You have to be very consistent. So one thing that I did on this, I trained them every month. So you have to schedule a sync or training every single month to train them on security or secure development. So one thing that you can also have with the security champions is job shadowing, because most of them, the way I've noticed is they want to pivot even to cybersecurity. So that would be a good avenue for them to join even your cybersecurity departments. So great place for you to just create an avenue for them. So we still have silos, as we mentioned earlier, for the devs, the sec, and the operations team. So you'll see that the developers want to code and test and want to deploy. The security guys want to assure security and compliance, and the ops team want to run everything to run reliably. The operations teams want to make everything standard. They want to maintain the environment, while the developers want to push changes as much as possible. And then security, we want to enforce that everything is secure throughout. So working in silos has been a very big issue in implementing DevSecOps initiative. So one thing as well that we also have to really work on for developers is to change the way we do tracking. So for developers, we have to make sure that we are tracking these key things in the pipeline throughput. We have to check for time to build. So whenever you've integrated security within your DevOps pipeline, so what is the change of the time to build? What's the change of the time to test? What's the change in the time to deploy? As well as time to improve? What are the failed and flaky automations as well? And what are the escaped vulnerabilities per pipeline stage? And what are the false positive rates? Because if you have false positive rates that are quite high, because you'll be wasting a lot of time for the developers trying to fix issues that are actually not there. So apart from having the pipeline throughput, you also have to check for live site health. So by live site health, we are saying we're looking at, these are the three main things that we look at: time to detect, time to communicate, and time to mitigate. You have to make sure that you have these stats inbuilt within your environment to make sure that you have these health checks every so often. So other things apart from the three main is the customer impact, customer support metrics, incident prevention items, as well as SLA per customer and time to patch. But the three main things that you have to check for is time to detect, time to communicate, time to mitigate. You also have to make sure that your developer pipelines are secure as much as possible. So you have to adopt a centrally governed and secure engineering system. So if you have decided that you're using this particular pipeline, make sure that you do a lot of threat modeling as well to see what actually can go wrong within your particular adoption or pipeline. So you also have to allow only trusted and approved authorized DevOps pipeline actors within your environment. So whenever you try to secure the DevOps pipelines, you're trying to prevent build tampering, because you can be able to, you can imagine that you've built something secure and then someone goes in and pushes something that is insecure. We're also trying to prevent unauthorized access to package repositories and production infrastructure as well. So some of the other things that we look at while trying to secure the DevOps pipeline is your compilers. How are you actually signing? Are you actually signing properly with validated signatures? Are you actually protecting your builds, and are you verifying your builds to be actually secure? Are you checking your build machines and infrastructure? This is where we also look at infrastructure as code. We also look at DevOps services, whereby we make sure that the managed identities and sensitive tenants are in isolation. We look at compilers and user processes, so we have to make sure that they are always isolated and locked down in environments as well. You also have to make sure that your software on build machines are signed properly with validated signatures. So this as well will go in to prevent compromised compilers and build machines, and as well as compromised dependencies. So you can just take a moment even just to grab that and make sure that your DevOps pipelines are as secure as possible. Another thing that you have to make sure is you harden pipeline access as much as possible. Because this will prevent compromised credentials and malicious insiders. So whenever you're doing a review of your pipeline access, you have to make sure that you're using proper device policies, like you can integrate to AAD, as well as other device policies, and make sure that all operations are adhere to least privileged principles. If you don't require something, you shouldn't have that right. Make sure that you have the least privilege as much as possible. Regularly scan your identities access management to make sure that if someone left, they shouldn't have access, and if someone has a lot more privileges, you should be able to revoke them. You also have to make sure that you have multi-factor authentication within your pipeline as well to make sure that it's secure. You also have to ensure that you enable endpoint protection for all your workstations and allow only registered devices throughout your adoption as well. You also have to make sure that you're checking for injection if there's any proof or any evidence of tampering within your pipeline. So that one you have to make sure during your monitoring as well. So this is the interesting part where we check for security within your development lifecycle. So development lifecycle we're talking about now from all the way from pre-commit to operation and monitoring. So in your pre-commit, the key of security that you have to integrate is threat modeling. Threat modeling, you're trying to see what avenues can be used to get into your system, what avenue can be used to get into your infrastructure. You're trying to see what a black hat would actually use, the threat actors that they would use to get into your system. And you're also doing IDE security plugin. This is where I mentioned that there are several security extensions that you can use to integrate in your IDE and get security whenever you're coding. We also have pre-commit hooks, so that before you even push your code to your repository, it prevents you if it gets something like secrets within your code. You also have secure coding standards. So one thing that I've seen us doing wrong is pushing or giving developers a whole list of whole Excel showing best practices and telling them that you should adhere to this. The right way to do it is to train them on actually how to use these automated security tools and how to address those issues. Another key thing to do is to do peer review. You have to make sure that you have someone else within your team who is able to review your code. So during the commit, we are doing static code analysis. By static code analysis, we are crawling through your code to check for vulnerabilities. We also have security unit tests. If that particular check is actually passing, we're checking for dependencies management as well as credential scanning. So we'll look at a couple of tools that you can use to do during your commit stage as well. So we have the next stage for deploy. So here we're looking at infrastructure as code. What tools can you use to make sure that your infrastructure is as secure as possible? We're also looking at dynamic security scanning. We're making sure that your cloud configuration checks are secure and your security acceptance tests are met. And the next part is looking at operating and monitoring. This is where you're making sure that you have continuous monitoring, integrating maybe through a SIEM, doing threat intelligence, and as well as blameless postmortems. So by blameless postmortems is in case of a breach, no one is blamed. So you learn from a particular incident response. So there are 3 things for securing the developer workflow. Make sure that you have met these 3. So you have to deploy a developer-first tooling. So a developer-first tooling is one that they can actually easily integrate and that will actually work for them. And you have native and built-in security capabilities. So these toolings should have security capabilities, so at least they can be able to embrace them instead of always integrating new tooling and training them on new tools and making it very complex for them. The third is automation, making sure that you've automated all these processes within your pipeline and making it easier for them to identify the vulnerabilities and fix them. So remember, I mentioned for the commit, we check for secure dependencies. So this is where we look at open source libraries as well as other third-party dependencies that you are using within your code. We mentioned that 80 to 90% of your code is actually third-party or open source. So in here, we have several tools that I personally use. We have Dependabot, which actually checks for all these dependencies and gives you an accurate list of the dependencies and the vulnerabilities. We have open source tools that are there that you can use. Some of them that I personally use are Safety, OWASP Dependency Check. We also have Retire.js. We also have Sneak, NPM Audit, Audit.js, White Source Bolt, .NET CLI. We also have local PHP security checker, Chelsea. We have very many. So what I usually do, if you're interested in playing around with these tools, we have several vulnerable applications. So you have like WebGoat. If you are a Java developer, you can go in and play with WebGoat and deploy them and just try to work around with these particular vulnerabilities and see how they work. I hope time is not. Okay. You have to make sure that you have to check for dependencies because remember, as you said, 80 to 90% of breaches are in your dependencies. We also have this open SSF scorecard, which you can use to get all these open source vulnerabilities. So it prevents dependency hijacking as well as dependency confusion. So go in and just search for open SSF scorecard and play around with it because it has been contributed widely in the industry. It will give you a wide range of the vulnerabilities within your open source. So just, yeah, you can just take some time just to grab that. And so apart from dependencies, we also have to run static and dynamic analysis. So by static analysis, we're looking at your code to make sure that it has no vulnerability, it gives you vulnerabilities without actually running the code. So it just crawls through your code. And then for dynamic analysis, is an application that's already running, so it crawls through runtime and just gives you the security vulnerabilities which you can be able to address. So some of the tools that I'd recommend for SaaS are stuff like CodeQL as well, SemGrep, Bandit, GoSec. It depends with the kind of language that you're using. Most of these tools, you have to know which one actually meets your requirements. We have a whole list of tools there. And one thing that I like, also OWASP has several of these tools published in their site, which you can go in and play around with and see which one actually best works for your environment. So for Dust, some of the tools that I've worked with is OWASP Zap. We also have Nikto, Babsuit. We have very many tools which can help you in dynamic analysis as well. So one thing that we always have to check for is hard-coded credentials. So within hard-coded credentials, some of the tools that I have worked with as well is GitHub Advanced Security, Trufflehog, Detect Secrets, Talisman, depending as well with the kind of programming language that you're using. Go in and check which one best works for you. So to prevent secrets from leaving the development machines and to detect previously leaked secrets. So one thing that I've seen, and I don't know if I should say this, but yes, you have detected your hard-coded secrets, and then you go in to GitHub, and then you create a merge request and say that this one, I will call it remove passwords. So if you just go in and you find, just Google that, remove passwords, you'll find a whole list of stuff that shouldn't actually be leaked, and you should probably just go in and remove that as well. So yes, we've mentioned a whole list of things. We've mentioned about security champions and how to actually build them and to maintain them as well, and how to deploy security within your software development lifecycle. So I'm going to end off with this slide. So once you have deployed a security-first mindset within your development lifecycle, you will definitely have happier customers. Who doesn't want happier customers? So you'll also have happier developers because you won't have that back and forth between you and the security folks, and you'll fix security vulnerabilities as soon as possible. You'll be able to ship code faster, so you'll have 30 to 50 times faster deployments, hence you'll make the big guys happier, and you'll have 200 to 400 times shorter lead times, as well as 21 times more features customers care about being pushed. So with that, I think I will leave it to you just for any Q&As in terms of DevSecOps.
So with the implementation of DevSecOps and all of these tools, do you find it difficult to scale if you have, hundreds to thousands of apps that you need to do this versus a smaller environment?
Sorry.
Is it difficult to scale?
Is it difficult to scale?
Yes.
So yes, it can be difficult to scale because I've seen scenarios whereby you are actually adopting a tool that is actually not scalable. So by that I mean you'll find that you'll use a Dust tool, which actually takes around 15 minutes to scan up one asset. That's quite definitely not scalable. That's why you have to be quite intentional about which tool you're actually deploying and if it actually works for you, but if it's actually scalable. Yeah.
I'm curious if you can speak to the SaaS tools and speak to it at an expert level. What do they do? What types of vulnerabilities do they typically find? And how do you deal with the noisiness and the false positives that can come out of SaaS tools? So extremely interested in just talking about SaaS tools generally and then more specifically.
Okay. So what SAST tools does, so it's a security application, static application security testing. So it crawls through your code and searches for maybe functions that are insecure, or it even checks for your code, like for queries that are maybe vulnerable to something like SQL injection. So it does that statically through fuzzing. Yes. So one thing that I've seen, for this particular area is, what was the other question? So yes, for SaaS tools.
How do you deal with some of the false positives that may come out of the tool?
Yes, so how do you deal with false positives that comes out of the tools? It's because you have to do, most of the false positives are because you've actually taken the tool as is. So you also have to do a DevSecOps maturity model within your whole initiative. You also have to do what we call, so you have to do a lot of tweaking of that particular tool to make sure you remove the false positives. Because when you use the tool as is, definitely you'll get very many false positives in most tools, as from my experience. So we have several models or maturity of DevSecOps. So you have maturity level 1 to all the way maturity level 4. So the more you mature, the less the false positives. Yeah.
What are some of the most prevalent findings that you would encourage people to address that come out of these SaaS tools?
Okay, so some of the vulnerabilities that I have seen, especially from SaaS, is in some cases whereby they're not using the best practices. They're using insecure functions, which are probably vulnerable to the OWASP top 10. So that one will probably be captured within your SaaS scans as well. Insecure deserialization, that one can be captured within your SaaS scan as well. Even SQL injection can be easily captured using some stuff like CodeQL, SemGrep as well. Yeah, I hope that answers. Yeah. Yeah.
So I happen to be one of those security-curious developers that you alluded to earlier in your conversation. So far, our code base is built in Go, and I think on your slide you mentioned, put Go a second there. So we've already got that set up. Now, for the curious developer like me, what more can I do to help take DevSecOps to the new level? Because our code base is interacting with a big legacy Java database, Java code base as well. So there's quite a bit to work through. So what can I be pushing for in addition to GoSec?
So what can you be pushing for? So it depends also, because that one would just be looking at your application security only. Remember, you still need an environment whereby you're deploying it too. So you'll be looking at infrastructure as code as well. So those are some of the stuff that you have to push for. Making sure that your infrastructure is secure, compliance as code, making sure that your environment remains compliant. That's why we talk about stuff like Ansible, just to make sure that you are capturing the correct checks. We're also looking at, so the important stuff. You're looking at software composition analysis, SAST, crawling through your code, Dust. Make sure that you're regularly checking, doing regular scans at least once a week on running applications as well. And making sure that, so one thing that I do not actually recommend is to do like brute forcing attacks like on existing systems. Or maybe you have it on a different environment, have it deployed on a different environment whereby you're regularly scanning it, but don't run it against your public or your public-facing environments, because you'll probably bring down the system. So you have to have an environment just for testing your systems.
Oh, so just like how you have a dev, a QA, and a staging and prod environment, make another separate one for security, pen testing, and have at it there.
Yes.
Okay.
Yeah. Any last question? Okay.